everybody. In this video we will learn Objective 2B, our gas law calculations. We have 5 separate gas laws that we will learn in this objective, but they are all pretty closely related to each other. These are our variables that we'll be dealing with in our gases unit. P stands for pressure, V for volume, T for temperature, and lowercase n for moles. It's very important that it be lowercase n. You also need to familiarize yourself with the term STP. STP means standard temperature and pressure. Anytime you see STP, that means the temperature is 273 and the pressure is 1 atm. It is very important to remember that in all calculations for 2B, all temperatures must be in Kelvin. You will not get the correct answers unless your temperatures are in Kelvin. These are our gas law equations. We do have separate equations for each of the laws. However, Boyle's law, Charles' law, and Gay-Lussac's law all combine together to form the combined gas law, which is this equation right here. So by figuring out what variables we have, we can figure out how to alter the equation to fit what we're doing. And Avogadro's law is right here, and this shows us the relationship between volume and number of moles. These equations will always be given to you on a quiz or a test. Okay, so this is our first example problem. We have a sample of gas that has a volume of 30 liters at 38.3 degrees Celsius. So we have 30 liters for V1. We have 38.3 degrees Celsius for T1. However, we want that to be in Kelvin. So in Kelvin, it is 311.3 Kelvin. And we're cooling it to 12.9 degrees Celsius. Again, we want that to be in Kelvin. So 12.9 degrees Celsius is our T2. In Kelvin, that is 285.9 Kelvin. What we're trying to find out is what the new volume of this gas will be at the new temperature. So we will be looking for V2. Now this problem says nothing about pressure and it says nothing about moles. So we know we're only looking at the relationship between volume and temperature. So now that we know what our variables, our next step is to figure out which equation we're going to use. Nowhere in the problem do we talk about moles, so we know it's not going to be Avogadro's law. So we're going to use the combined gas law. In this problem, though, we only deal with volume and with temperature. We're not talking about pressure. So we're just going to cut pressure right out of the equation, and we're going to use V1 over T1 equals V2 over T2. So plug in your variables. So it's going to be 30 liters over 311.3 Kelvin equals V2 over 285.9 Kelvin. So when you solve for V2, you should get 27.6 liters. Okay, here is example problem number 2. A 0.755 liter sample of gas at a pressure of 112 kPa. 0.755 liters is our V1, and 112 kPa is our P1. And we're compressing that gas to a volume of 0.555 liters. So that is our volume 2. And we want to know what the pressure of the gas sample is when it is compressed to that volume. So P2 is what we're looking for. So here, the problem does not mention temperature at all or moles at all. So our next step is to figure out which equation we're going to use. Again, the problem does not mention moles at all, so we're not going to use that one. The problem does mention pressure and volume. It doesn't mention anything about temperature, so we're going to drop temperature out of the combined gas law equation. And we will use P1 times V1 equals P2 times V2. So take our variables and plug them in. We have 112 kPa times 0.755 liters equals P2 times 0.555 liters. So when we solve for P2, we should get 152.4 kPa. Example problem number 3 says a quantity of gas exerts a pressure of 450 millimeters of mercury at a temperature of 58 degrees Celsius. So 450 millimeters of mercury is P1, and 58 degrees is our T1. However, remember we want that to be in Kelvin, so that's 331 Kelvin. If the volume remains unchanged, we can cross volume out because it tells us that volume is not changing. We want to know what pressure it will exert at 14 degrees Celsius. So 14 degrees Celsius is our T2. In Kelvin, that is 287. So P2 is what we're looking for. So looking at our equations again we have no moles in the problem, so we know it's not that equation. The problem gives us pressures and temperatures and tells us that volume remains unchanged, so we're going to take volume out of the equation. So we're going to use P1 over T1 equals P2 over T2. So plug in your variables. We have 450 millimeters of mercury for P1 and 331 Kelvin for T1. We're looking for P2, and T2 is 287 Kelvin. So when you solve for P2, you should get 390.2 millimeters of mercury. Example problem 4 says a gas with a volume of 4 liters at a pressure of 0.9 atm is allowed to expand until the pressure drops to 0.2 atm. So 4 liters is our V1 and 0.9 atm is our P1. We are expanding the gas until the pressure drops to 0.2 atm, and we want to know what the new volume of this gas is, so we're looking for V2. No mention of temperature or moles, so we're not going to include those in this problem. So looking at our equations again, we know it's not this equation because there's no moles. And we know we need to drop temperature from this equation because there's no temperature mentioned in the problem at all. So we're going to use P1 times V1 equals P2 times V2. So plug in your variables. 0.9 atm times 4 liters equals 0.2 atm times V2. So when you solve for V2, you should get 18 liters. Example problem number 5 says if a helium balloon has a volume of 3,400 milliliters at 25 degrees Celsius and 110.3 kPa, what is the volume of that balloon at STP? So 3,400 milliliters is our V1. 25 degrees Celsius is T1, but remember we want that in Kelvin, so that's 298 Kelvin. And P1 is 110.3 kPa. Now it may look like there's only 3 variables in this problem. However, remember STP means standard temperature and pressure. And our standard pressure is 1 atm, which is the same thing as 101.325 kPa, if you remember from our pressure conversions in 2A. And standard temperature is 273 Kelvin. Okay? And the problem is asking us to find volume 2. So no mention of moles, so we're going to get rid of that. So we know we're not going to use this equation because it didn't talk about moles at all. The problem gave us pressures, volumes, and temperatures, so we're going to use the whole combined gas law the way that it's written. So plug in what you have. 110.3 kPa times 3,400 milliliters over 298 Kelvin equals 101.325 kPa times V2 over 273 Kelvin. And you're going to solve for V2, and you should get 3,390.7 milliliters. Okay, now since our volume was given in milliliters, we know our answer is going to be given in milliliters also. So we don't need to change volume to liters here. We just know that our answer is also going to be in milliliters. All right, example problem number 6 says a 6-liter sample at 25 degrees Celsius and 2 atm of pressure contains 0.5 moles of a gas. So 6 liters is our V1. 25 degrees Celsius is our T1. Again, we want that in Kelvin, so that would be 298 Kelvin. At 2 atm, it contains 0.5 moles of the gas. Okay? If an additional 0.25 moles of gas at the same pressure and temperature are added, what is the final total volume of this gas? Okay? So it says same pressure, so we know pressure is staying atm, and since it's staying the same, we can just cancel it out. We don't need to include that. And it also says same temperature, which is 298 Kelvin, but again, since it's not changing, we can just cancel it out. So we are adding 2.5 moles of gas to the container that already contains 0.5 moles. So our N2 is not 0.25, it's 0.75 moles because we're adding that. And we want to look for the final volume. So V2 is what we're going to be looking for. Okay, so the variables we're given are volume and moles. So we're going to use this equation because this is the only equation that has anything to do with moles. The combined gas law doesn't have moles in it. So plug your variables into the equation. We have 6 liters over 0.5 moles equals V2 over 0.75 moles. And when you solve for V2, you should get 9 liters of gas. So this is all the example problems for Objective 2B. You have some practice problems that you can work on in your packet. Please let me know if you have any questions.